All right, so problem number 7. I'm going to have a few hints for the note card. So just to put this out there, we have a cheetah accelerating uniformly from rest, and it reaches a speed in 2 seconds. And I'm sorry, I'm using a different way of writing these letters, and I'm just going to change this. So this should actually be x naught. This will be x. This will be v naught. We'll put v right here, and a and t we'll leave alone. First, the first thing is on these problems, always make x x naught equal to 0. The next thing, from rest, like from rest, or starting from rest, that means v naught equals 0, okay? Versus comes to rest or comes to a stop, or comes to a stop means v equals 0. And also drops means two things. It means the initial velocity is 0, and it means that the acceleration is 10 meters per second squared because of gravity. I'm going to correct that. And so 10 meters per second squared because of gravity. Okay. And then lastly, what I wanted to point out is that, whoops. There we go. And then if something falls, it also means that a is 10 meters per second squared. And both of these are because of gravity. Okay. So those are good things to know, and those are things we're going to want to have on our index card. Okay. Now, here, let's go ahead and use this to solve some problems. So we're going to start at a speed of 0. We don't know how far it's going to go. We know it starts at a speed of 0 because it says from rest, using that hint. V final is 29 meters per second. The acceleration is unknown, and t is 2 seconds. So first thing, let's get its acceleration. Let's try v equals at plus v naught. So that's going to be whoops, 29 equals a times 2 plus a starting velocity of 0. So a is going to be about 14.5 meters per second squared. Okay. Now, the next thing here is let's get the displacement. So I'm going to use x equals, for this next one I'll use x equals 1/2 at squared plus v naught times t plus x naught. And then I'll plug that number in. So working up here, I'm going to get x equals 1/2 times 2 times 4. Let me try that again. 1/2 times 14.5 times the time squared plus 0 plus 0. And so our final position is going to be 14.5 divided by 2 times 4 is going to give me 29 meters. All right? Now, part B. A car is moving at 20 meters per second. It decelerates to 15 meters per second over a distance of 20 meters. We want to know its acceleration, the amount of time it takes. I feel like I said that really quickly. Okay, so x naught, 0. So decelerates, that's the speed it ends up at. So it ends up at this speed having started from this speed. And we know this is 20. We don't know the acceleration, and we don't know the time. Since we don't have time in this formula, I'm going to use this weird formula here for when they don't give me time. That being the case, I'm going to say 15 squared equals 20 squared plus 2 times a times 20 minus 0. And so I'm going to get 225 is, let me make sure that's right. So 15 times 15, yep, 225 equals 400. Now, when I multiply all the stuff in the parentheses, this is going to end up being 40 times a, by the way. I'll take away 400 from each side. Take away. I still talk like I'm in 3rd grade, but I don't care. It helps me understand my math. So I get negative 175 equals 48. I kind of escalated that, didn't I? Okay, equals 40 times a. Let's divide both sides by 40. And then we're going to get an acceleration. So 175 divided by 40 gives us an acceleration of negative 4 I'm going to say 4 meters per second squared. And the time it takes, let's use v equals at plus v naught. So that's 15 equals negative 4.4 times t plus 20. So that's going to give us negative 5 equals negative 4.4 t. And I'm getting that the time is going to end up being 1.14 seconds. So there's that number, and then there's this number. I'm just going to circle these so we have them all ready to go. All right, so that's page 1 of problem 7, and I'm going to do page 2 of problem 7 in the next video.